Good afternoon, everyone. So I'll be talking about microgrid and how it could be helpful in enabling resilient and cost-effective access to power. So energy and grid transformation has been happening, and it's gaining pace over the time. So what we see on the left-hand side is a traditional structure of a grid where power generation was at some location far off, and there were long transmission lines which certainly coexist. But what has been added over the years are generations at various levels. So at penetration of generation is happening at all the level in the grid, and hence the transition has been from a centralized grid structure to a more distributed grid structure. So energy and grid trending towards increased complexity at lower cost is the need of the hour. As we see, what it started was with a very small systems and very few components of distributed energy, and over the period it has now moved to a commercial complexes as well, and we see that in the future large installation of distributed energy resources will be integrated in the grid, and that will be one of the major drivers for the microgrid technology as well. So coming to the definition of microgrid, so it's a different distributed energy resources and loads that can be operated in a controlled, coordinated way, either connected to the main grid or it could be an isolated from the main grid. Nanogrid is primarily a smaller system which we foresee would be something which will be the behind the meter, maybe connected to one building or one individual complex. This is a very relevant slide. I would like to spend some time on this. This basically covers the entire diverse range of applications of microgrid. So if we see from the extreme left hand side, so here are the different conditions of the grid. There could be no grid conditions, that's the places which is far off where the grid cannot reach. There could be a situations of a weak grid. So the wires are available, but the power reliability are very low. It's a very typical case in India where we see that many places the power are available for maybe 4 or 5 hours, not for the entire day. And as well, there could be a driver for a fully connected and a reliable grid as well. So the different segments which are relevant for microgrids, as we have distributed it, are island utilities, remote communities, industrials and commercials, defense, urban communities, institution and campuses. And I have been working on this especially in India. My area of operation is India, and I have personally seen that there are different drivers and cases for all this. The time will come by when this technology is fully absorbed by the system. So slowly it is now catching up. And what you see on the top are the different So there are various drivers for this. This matrix basically encompasses the mapping between the different drivers and the different segments. What we see as a tick mark is the main driver, and what are in the brackets are the secondary drivers for this. So on the segments, the drivers could be a social impact, especially in the rural segment where people are deprived of power. So microgrid is used to make power available for them. There could be economic factors. So in one of the slides, I'll be covering that as well in further slides. So for the cost of electricity, there could be environmental impact. So people are becoming conscious, and there is a push for putting on the renewables for the rooftop as well. And there could be also operational aspect as primarily the reliability of power and independence of fuel. So this is a typical representation of a grid connected microgrid where various generations and loads are available in a given geography, and all are being controlled through the available control technology and the communications. And this is a typical representation of off-grid microgrid. It could be an island utility as one of the most I will say the relevant case in India is Andaman Nicobar Island, where a lot of projects are there in offering at various stages, including one which is being done through Swedish Energy Agency. The next, this is basically the top graph. We try to map some typical parameters of cost of DG, number of hour of uses of DG vis-a-vis the cost of storage and the control technologies, and what could be a typical ROI. This certainly will change, but it will not be fixed. It will be varying on the cost of diesel and certainly on cost of the storage. We see that storage coming down, the cost of storage rapidly coming down. The technology will be certainly catching up rapidly in the times to come. And the ROI will be much more attractive, and people will be inclined to take this technology further. This is a representation of microgrid application, how we could help in smoothing the curve. The top one is a typical solar curve, where we see there is, because of some cloud, there are interruptions, and the energy flow output is not even and smooth. And that can also be catered and controlled by microgrid technologies, by adding some storage. And the bottom one is an output of a wind generator, which is very rough, and that also can be smoothed out with microgrid technologies and improving the predictability and the reliability of the generations. This is a typical representation of an entire system. What we could see, the technology, what we offer is a system based on distributed architecture. So the central control system actually controls each and every different controllers which are connected to their respective generations, and they are capable of controlling and managing those type of generations, be it wind, be it diesel generator, PV plant, or it could be also a system connected to the main grid. On the right hand side, we see the different loads. So an application of load management system is also built into this microgrid technology, so that in case the situation arises that in spite of all the generation being available, the load is higher, you can also do a management on the load side and ensure that you meet the entire system requirement with the available generations. So it's about balancing the entire system. So this is basically operational goals and power system function driver, which actually drives for the choice of technology. So what we see, they are basically 8 S which can be catered to the microgrid technology, and those are stabilizing, spinning reserve, STATCOM, that is static synchronized compensation, seamless transition between island and grid connected states, standalone operations, smoothing, shaving, and shifting. So these are the typical application by putting the right technology, right combination of devices, controller, and sizing it well. We could actually achieve all these 8 functions through these microgrid technologies. I'll just touch upon about ABB in microgrid. So this is one of the key components for microgrid. What ABB has is called power store battery, and this is what we are delivering from here in India for all over the world. And it's a reliable, containerized plug-and-play microgrid solutions. It could house the battery, the solar inverter, and all the other control technology which are required in one single container. Well, it depends upon the size, obviously. So if larger systems are required, we may have to put in more container. But the system is very flexible, modular, and it's kind of designed to make it operational in a plug-and-play manner. So, okay, I'll skip this. This again talks about the different applications area which I've already referred. This is the microgrid plus controller. So this is what I referred in my previous slides. So this is the one which is a distributed architecture technologies, where the central intelligence is there and you have the controllers for all different generations connected to their respective endpoints and controlling them. So this is another technology which is typically for improving the penetration of solar. So if you have solar connected and it's primarily working on that to improve the penetration of solar along with DG, it's important that that the controlling is done to ensure that it's in case of low load, that solar should not backfeed the DG and the DG trips, and which would ultimately lead to entire power outage. So this PV diesel controller actually optimizes the penetration of solar into the system. Then we have consulting in design tools and remote service operations. This is a summary. Basically, we are available in microgrid into the entire complete life cycle, starting from consultancy, design engineering, simulation test, supply, installation, commissioning, as well as after sales services. Some of the references, we have got around 30 references across the world. If you see, most of the concentration are in Australia. That is because the drivers are very high in Australia, and secondly, we had acquired a company in Australia which was in microgrid called Power Corp. So I'll just take some examples. So this is a case where 4 into 320 megawatt diesel, 300 megawatt of PV, and 500 kilowatt of power store flywheel. So we had used a flywheel technology here, and the benefit was reduction in carbon, improvement in the uses of solar, as well as reduction in the cost. This is a Juhi Island project where again we are supplying the power store and the control technologies. And here also there is a huge reduction in carbon emission because of the incorporation of these technologies, as well as the PV has been effectively being put in use over here. This one is a project in Kenya where we had used a flywheel technology to smoothen down to improve the stability and power output from a wind turbine. So finally, because of this microgrid, the output energy has been smoothened, and the power is very stable and reliable there. And this is one of the installation which we have done in our own factory in Johannesburg, South Africa. And here basically the power supply was available, but there was a lot of intermittency and the cost of power was also very high. So this project in fact addressed two main challenges of reliability of power as well as cost of power. In line with this, we are going to install one system at our works in ABB Baroda. That will be operational in, I guess, in June or July, which is at 1.2 megawatt and 600 kilowatt hour of storage, with connected to the DG as well, DG and the grid. So that's all from my side. Thank you.